what's unique and still unsolved about virtualizing GPU especially?
Actually, creating the ability to virtualize was a difficult process. To actually, the goal on the technology side was to build efficiency, right? You wanted to efficiently, we had smart schedulers that would track, how busy the workloads were, and sort of scheduling tasks to run across different CPU cores and so on, to sort of do this Tetris thing of, fitting workloads onto the, in the most efficient way possible. And it took us years to get to the sort of maturity level that we have today. I mean, back then, CPUs from Intel and AMD didn't have extensions to support virtualization, so we had to do it all software. And we helped those guys design the hardware to support it and optimize virtualization. Now, of course, a lot of this stuff just runs natively and people take it for granted that it happens, right? The GPU space is very much, it's hard to do it properly, but at least workloads running on GPUs do not utilize the GPUs that efficiently. There's a lot of idle time across the GPUs. They're sitting there waiting to process workloads. Having that ability to deploy workloads much more efficiently across GPUs is really the key thing, and that's what we're focused on.
But where do you think it goes from here?
I think the industry will evolve in many ways. I think, we're starting to see more hardware players coming onto the scene. Power efficiency is one of the areas that I think we'll see some innovations in that space. And also, I would like to think, just like we did with the CPU vendors, I would like to think that we'll start to see capabilities coming into the hardware itself in order to more efficiently support virtualization. There's this sort of inflection point, I think, where the hardware vendors accept that they can't control everything in the market, and they have to accept that virtualization is a thing. That happened in the hardware space for CPU vendors